Welcome to Review Recording 1D to accompany Instructional Recording 1D on Unit 5, Chapter 5, Section 5.1 of Mathematics 2200. We'll do a couple of examples related to adding and subtracting radicals. In Example 1, we're asked to determine a simplified expression for the value of x, x being this little piece of the diagram right here. Let's see what we're given. We're told all of this length right here is root 27 plus 4 root 20. And we're told this little length right here is the square root of 125 plus the square root of 3. If all of this is root 27 plus 4 root 20, that means it would be the same length over here. Root 27 plus 4 root 20. So it would appear that all we have to do is take the longer length, all of that, and subtract this one to get the value of x. So x is equal to the square root of 27 plus 4 square root of 20, subtract, make sure you use these brackets, square root of 125 plus the square root of 3. We do not appear to have any like radicals. However, off to the side here, I'll do some simplification. Square root of 27, same as square root of 9 times the square root of 3, which gives us 3 root 3. 4 times the square root of 20 is equal to 4 times the square root of 4 times the square root of 5. Square root of 4 is 2, so we have 2 times 4, which is 8 root 5. And finally, the square root of 125, that can be thought of as the square root of 25 times the square root of 5, which gives us 5 root 5. So back to the problem here, we actually have 3 square root of 3 plus 8 square root of 5, subtract 5 root 5, and the square root of 3, we couldn't do much with that to simplify it. Distribute this negative to these two terms. We have 3 root 3 plus 8 root 5 minus 5 root 5 minus the square root of 3. The terms that are like are the 3 root 3 minus the 1 root 3 plus the 8 root 5 minus the 5 root 5. 3 root 3 minus 1 root 3, we don't normally write the 1 in front there. That gives us 2 root 3, and 8 root 5 minus 5 root 5 gives us 3 root 5. So B is our answer. In this next one, we're asked to simplify completely. Now, since we're doing a lot of adding and subtracting, we need to convert our radicals to their simplest mixed radical form. So let's work on that first. 2/3 times the square root of 12. We think of the square root of 12 as square root of 4 times the square root of 3, which gives us 2/3 times 2 times root 3, which is 4/3 times the square root of 3. 4 root of 200, let's work on that. We have 4 times the square root of 100, because 100 has a perfect square root, times 2. So we've got 4 times 10 times the square root of 2, which gives us 40 root 2. Now we've got to work on the 1/2 square root of 48 as well. 1/2 square root of 48 is equal to 1/2. The largest perfect square factor of 48 is 16, so we have square root of 16 times 3, which gives us 1/2 times 4 times the square root of 3. 1/2 of 4 is 2, so we have 2 root 3. Next we work on the 6 square root of 50. that is equal to 6 times the square root of 25 times the square root of 2. 25 being the largest perfect square factor of 50. So we have 25, square root of 25 is 5 times root 2 left there. We have 30 root 2. So our problem becomes 4/3 root 3 minus 40 root 2 minus 2 root 3 plus 30 root 2. Getting our like terms together, 4/3 root 3 minus 2 root 3 and minus 40 root 2 plus 30 root 2. This one's pretty straightforward. Negative 40 plus 30 is negative 10 root 2 when we subtract or add those. Now, for this one, we really have to think about a common denominator. We think of this as 2 over 1. So our common denominator is going to be 3. So we've got 4/3 root 3 minus 6/3 root 3. Those are like, and we have like denominators. So now we just subtract 4/3 minus 6/3 is negative 2/3 root 3 and bring down that minus 10 root 2. And we're done. In conclusion, like radicals have the same index and the same radicand. Like radicals can be added and subtracted by adding and subtracting the coefficients in much the same manner as like terms. For example, if you had 2x and 3x, they'd be like terms. Sometimes unlike radicals can become like radicals when converted to their mixed radical forms.